So our company name was Assistive Associates, and this is the wheelchair helper.
So our team's motto is solving your problems through technological and mechanical innovation. Hello, I'm Allie Miller. I am a senior here at Grassfield, and my intended major is a systems engineer.
I'm Noah T. Skitter, and I'm also a senior at Grassfield High School. My intended major is architectural engineering.
So the problem that we chose has to do with the field of disability. We noticed that people who use wheelchairs have a lot of restrictions with what they can do. Like one of these restrictions is they can't really carry around their commonly used items as much as they would like. There are some products that solve this, but not really effectively. People who don't use those products have to place bags on the back of their wheelchairs, and these are very hard to access. So we wanted to make a product that had a optimal level of both storage and accessibility. So that led us to our main problem statement, which is our team will develop a unique assistive device that will allow the wheelchair user to adhere their own personal bag to the chair, as well as give them a way to easily access this.
And then validating the problem. Validating the problem, we selected 20 of our classmates and we had them test it for themselves, seeing how difficult it was for them to actually pull the backpack up, timing them, and we took a survey and unanimously everyone said that it was difficult for them to get the backpack off. I actually, during one of our days as we get to dress up and we had Senior Citizen Day, I actually went the whole day with the wheelchair, going class to class with my backpack, and I eventually just left it on my lap because it was just so difficult getting up and off consistently throughout the day. And then we also had 10% of the students say that it was just uncomfortable to sit in with it behind them. Oh, and then in informal interviews, we asked them do they find it difficult to retrieve the bag themselves, and it was unanimous yes, as we just tested. And then we asked, do you find it difficult, and on a scale of 1 to 10, how difficult? It was ranging from 6 to 10, depending on the user. And then we also asked if they had bought devices to solve the problem before, and if it had solved it to their liking or not. And a lot of them said that it works, but it didn't work to the standards they wanted it.
What Noah meant to mention beforehand was that the informal interviews that we conducted were with people that we saw in our daily lives, people who use wheelchairs or their relatives use wheelchairs, and we saw them having extraneous bags that they put on the back of their chairs. Okay, so prior solutions. So we researched some prior solutions which can be categorized into 4 different categories, and we named them based on where the storage compartment is located on the chair. So we have on the upper left a back-based chair, or a back-based product, upper right the undercarriage-based, bottom left armrest-based, and bottom right wheel-based. So these products have some positives and negatives. We found that the undercarriage held a lot of stuff and was cost effective, but it was also hard to access, like we said earlier. The armrest base held some stuff, it was smaller, but if it rained, all your equipment would be subjected to the weather. Undercarriage based, because you're in a wheelchair, you probably have limited mobility of your legs, so moving your legs out of the way to access your belongings is probably not going to be a good idea. And then wheel-based, this can only hold flat objects, even though it's a good use of space, and these objects are going to roll around, which you can't really help.
So we had our design goals. Our main goal was so that the user would be independent themselves. They didn't have to rely on someone to get their bag for them. And then secondly, we wanted it to be easier so that work and energy and time would all be saved using our product. And then thirdly is we wanted minimal danger to the user and the people around them, so that if there was no sharp objects for the user to hurt themselves with or someone else when they were getting their bag.
All right, so brainstorming our product. Initially, when we were brainstorming, we went through a lot of different ideas, but the idea that we focused on the most is what we called an L-shaped bar, which is basically a bar in the shape of the L, and we thought it could rotate back and forth, and we brainstormed different ways that we could move this bar. So the first one is just some rough sketches of what we came up with. Then we thought we'll take the L-shaped bar and we'll put a gyroscopic bag on it so it can flip both ways. It's flat, it takes up less space than a bag that's bulky and sticking out. Moved on to maybe we can move the bag electronically, have some circuitry wired up, you press the button, it flips the bag around, you press it back, it flips it, so you don't manually have to move it. Then we had where you put the L-shaped bar on top of the wheelchair and you have a bag attached to 2 rings and you slide this bag back and forth so it's over here and then you can slide it back behind you. Then we thought maybe use a gear system with a gear ratio that it spins a number of times to get it to go here and then back the other way so you also don't have to move it yourself. But what we ended up deciding on, we used a design matrix and we went through all of the ideas and what we called a mechanical system, which is you manually moving the bar back and forth, is the idea that won. We thought it was the simplest, easiest to make given our time constraints. And then this is us, we did some rough prototyping before we came up with the project with some stuff we found around in the classroom, so wood, PVC pipe, and some duct tape. So here is the modeling of the designs. The first one is very simplistic. The L-shaped bar is made up of 2 bars with an axle, so only the top portion rotates. Very simple. We thought we might be able to up it up. And then the second one was very complex. It comes with 1 single bar that fits inside a cylinder, but this bar is bent at 90 degrees and then also has another bend. We thought that might be too hard. So the actual design that we came up with is a bar that fits inside and another one that has an easy 90-degree gradual change.
All right, so creating the prototype itself, we wanted to come up with a bar to support all this weight that was relatively strong, but yet would not break under contact and would not be too heavy for the user to use. So we actually used steel conduit. This was a 1.25-inch pipe and then a 1.5 pipe on the outside, so that there was room for it to move, but it wouldn't be too much for it to break. And then we ended up using the saw to cut down pipes. We each bought 2 10-foot pipes, I want to say, and we cut them down, and one of Spencer's friends was gracious enough to bend the pipe for us to 90 degrees so that we could have the specific bend we wanted. And then we used clamps to attach it to the wheelchair itself so that the wheelchair would be able to hold it and it can still collapse with it so that the user doesn't have to detach it every time it wants to collapse. And then we added magnets right here for it to pull off and stay secure on the whole way. And then there's one more. All right, that was when we were going in, we finished the final prototype, and then we added a non-corrosive paint to it so that it wouldn't rust over time and all of that jazz.
Okay, so this is our final project as you see it up here. It has 6 main components, what we call the rotatable L-bar, the fixed bar, the ring clamps, the maneuvering system, which in this case is your arm because you're using that to push back and forth, a hook for your bag, and then the magnets to attach it at the end and have it lock into place. Okay, so testing was a big part for us because we really wanted to validate that the solution that we came up solved the problem. So first we decided to create 2 methods of testing. We were going to time to see if using our product was quicker and involved less work. So on the left here you have what we call method 1, which is using our product. It involves a 240-degree rotation and then as well as a 10-inch horizontal movement to the right. On the other side you have what we call method 2, which is without the product. And this can be done in various different ways because you take the bag off yourself. And that's another way it could be done, lift up, then you turn. We used some force testers, both in grams and in pounds, to make sure that we got an accurate reading. So the proposed test that we want to do is to time to see how quickly it took us to use our product versus not using it, and also we calculated the work done in both methods. So the results of testing. First, in method 1, we calculated the work needed to be done by calculating the work you need to detach the magnet from the bar from the magnet, and then we calculated torque to find the work that you need to do to rotate it, and then we found the work that you needed to move it horizontally, which ended up being roughly 30 joules for the work in this system. And then without the product, we calculated vertical and horizontal movement, and then that came out to 70 joules. So 30 joules to 70 joules, we cut the work that you needed to do by over half. And then time trials, we did some testing and we found that it was quicker every single time to use our product versus not using our product, and that you had to hold the bag, which is in this case 15.6 pounds, for less time overall.
So improvements over time. Our product was designed for the student that was in high school, college, or even the middle day worker that's at work and they're just trying to access their backpack in and out throughout the day. And what we decided we could improve on it was the gear system we mentioned earlier. And if we added that, it would be able so that an elderly person could just theoretically just push a button and it would swing it to the side and push a button and it would swing it back. And that would be able to reach all different types of audiences to use this. And if we were going to do that, we would be able to hire a different engineer for a mentor that is good with electric circuits to design that gear system for us and help us out. Another improvement we would do is we would test it over time to see if it actually corrodes or not, the paint, and then any type of functions that would go wrong, testing it over time that we could not do over time for like a year period or two.
Another thing with improvements, the mentor we had, she was a worker at St. Jude's Hospital, and she worked with people with wheelchairs, so she gave us different helpful tips, but she wasn't really big on the technical aspect of designing the actual product. And then we have our citations, and that's it. Questions?
Great product. I think it's really cool. I design medical diagnostic equipment and I train therapy dogs. I spend a lot of time in hospitals and I see wheelchairs constantly. They almost always have a backpack slung over the handles and it's very awkward. 1,000 times I've probably gotten the backpack for some guy, hey, could you get my backpack? And this solved that problem. So I think this is really potentially a great thing. You need one more thing. You need the ability, a lot of people with different levels of disability don't have the ability to turn around. So you really do need that ability to sit straight up and get the backpack over here and raised up to this level.
Yeah.
So you need two motions. You have to do that. I don't think they need to be powered though. I think if a person can work a wheelchair, they have enough arm strength to be able to flip the thing around. So maybe just a lever attached that you could just simply reach back there and flip it around. And then some mechanism where you could lift it up. Because down here, it's kind of awkward for the same person. So if you could raise it up to eye level. But I think this is great. I mean, I know there's a need for it. I've seen it 1,000 times.
That was actually in one of our original designs, was for us to lift it up. When I had the wood, that was me lifting it up. We were going to have it in one of our original designs, but we would have to weld another piece to it and all the designs, and we didn't have a welder on site, so we couldn't get that aspect in. But yes, that was definitely one of the thoughts we thought. Yeah.
Hopefully soon.
We had a foundry line, so we could actually make castings in a different era.
Really nice work, guys. I'm glad to see that Mr. Spencer hasn't influenced everybody to the electrical world. As a mechanical guy, did you guys put any thought into what kind of capacity that vent pipe could carry? And
Weight load, we actually tested a lot of weight, and the bar itself did not break at all. Like it's pretty strong, big steel conduit.
yeah, you said an inch and a quarter, inch and a half pipe, something like that.
Yeah, that's exactly it.
Yeah, you could probably scale it down quite a bit, save yourself some weight on that. Maybe even put one on each side, just kind of offset them elevation. Yeah, but that's a very good start. You guys have done good work.
Thank you.
One note is it works okay on this wheelchair, but you want to watch the center of gravity. You start getting too much weight on the back end,
Yes.
might turn into a dragster.
Yeah, we almost added a counterweight at the front.
Yeah, I definitely agree that you would need some sort of way that a person with limited mobility could swing it around by pushing a button, either through spring-loaded or motorized. I think that would be a big improvement. And also, I think you might want to take this. You say you know someone who works with people in wheelchairs. You go ahead and take it when you're done with this class and put it on a volunteer's wheelchair for a week or two and see what kind of feedback they would give you through actual real-world field testing about how it actually worked out in real-life situations.
Absolutely.
Thank you, sir.
We can actually put it up right here. I never said that.
Another thing that we really liked is that we made a design that could fold up with a wheelchair. so you can take it places easier, it doesn't stick out.
That's important.
Yes, getting on planes.
How's the larger bike connected to the wheelchair?
We had it small, so it's just simple with skin planks like that. You put them on, take it off very easily.
Thank you.